proof is a simplifying problem, which we're doing. So doing the problems today is really going to help better prepare you for tomorrow. Even though proofs aren't on there, all of the stuff we're doing is the same. If you start working these, some of you will start to see things are happening. You're factoring, canceling, which we call divide when we use that for as far as a reason goes. You're multiplying by the reciprocal when you're dividing fractions. You can call that divide, or multiply by the reciprocal when we write our reasons. Sometimes you have to change using a Pythagorean ID to make it one word. Sometimes you need to change that one word into two in factors so that you can cancel. Again, it all depends on the problem. So when you're doing a proof, just like when we're doing our simplify, we don't want to skip any steps. You don't want to write something that's not true. Some of you are writing things in a previous step and then it makes it not true. It looks like you're just randomly multiplying by sign when really you're multiplying by the reciprocal, but that should be your next step. Don't write a bunch of stuff all in one step, because then you're going to get lost and I'm going to get lost and I'm not going to know how to follow your work. If you're ever in doubt, should I write that or not, just write it. Okay, if you have to sit there and think, should I show this step? Just show it, because by the time you show it, then you're going to move on to the next step of the problem and you won't have wasted any time. With the proofs, you always have to pick one side. It's not a solving, going back and forth, figuring out till you get them to be the same thing. You either pick the left or you pick the right, and you simplify whichever one you choose to manipulate. Usually the one that has more stuff on it is the one you're going to manipulate. And then we'll talk about this LHS, RHS when we get to the proof in a second, kind of the different ways that we like you to write a proof. Now, before we do that, multiplying. So if I write heart plus diamond, and I square that, I cannot distribute a squared to a polynomial. What this is heart plus diamond times heart plus diamond. That's what that means. As far as what did I just do there, right there, I expanded that. Okay, so if I wanted to have a reason for what I did that, when I get to the proofs, that would just be an expand. I did not factor that. Okay, I didn't do anything. I just rewrite. Okay, expand. I rewrote it in a different way. Like if I have sine squared x, that could be sine x times sine x. That's an expand. Or I could call that a rewrite. Either one of those would work. And then I'm going to actually multiply those together. So what am I doing? I'm going to multiply heart times heart, which is heart squared, heart times diamond, which is heart diamond, diamond times heart, still heart diamond, diamond times diamond, diamond squared. I'm using these shapes to show you that it works with letters and numbers, shapes, words. It's all the same. The skill is the same. So now, and that would be, what did I do? I multiplied. Again, with the simplify, we won't make you write. You don't have to write reasons. But if it's helpful to do that, then you can. Plus 2, I have 1 heart diamond plus 1 heart diamond, thank you, is 2 heart diamonds. 1 plus 1. There's not 2 hearts and 2 diamonds. It's 2 heart diamond. Heart diamond, think of that as like a 3x. 3x plus 3x is 6x. It's not 6 and then another 6x. It's just 6x. Plus diamond squared. What did I do right there? I added. And at that point, squared. At that point, there's nothing else to do. So again, that example is just to show you that whatever is here, if there's 2 terms being added or subtracted and we square it, there's no such thing as distribute a squared. You can do that into a monomial, meaning nothing with plus and minuses, but not a polynomial. Straight to here, yes. Because if you know, since it's the same, that creates 2 of whatever is the middle, that would be fine. So here to here, absolutely. Okay? All right, so cosine and tangent. This is what this unit is about. Cosine, sine, tangent. So that's cosine x minus tangent x. And if you don't have to rewrite it because you know how to square terms, then that's fine. You don't have to show that rewrite step. If you know how to square it without showing it multiplied by each other, that's fine. So now what am I doing? I'm going to multiply cosine times cosine, which is cosine squared x. I'm going to multiply cosine times negative tangent, which is negative cosine x tangent x. And then I'm going to multiply negative tangent x times cosine, which is still negative cosine x tan x. That order does not matter. Tan cosine, cosine tan, whatever order you want to write it in. I would suggest keeping it in the same order so you recognize they're like terms. But even if they're flip-flop, they're still like terms. And then negative tangent times negative tangent is plus tangent squared x. All right, so that leaves me with cosine squared x minus 2 cosine x tangent x plus tangent squared x. Now this cosine tangent might be able to do something with that. Cosine squared x minus 2 cosine x tangent is sine x over cosine x plus tangent squared x. So there is some more simplifying I can do right there. You want to be sure and show this. If I'm going to do some kind of simplifying, I need to show that I changed tangent to sine over cosine. And then those cosines, I can divide them out. Divide cosine divided by cosine is 1. So I'm left with cosine squared x minus 2 cosine x. Nope, sine x. Because cosine divided by cosine was 1. Plus tangent squared x. So now I look. I have a cosine squared and a tangent squared. For Pythagorean IDs, do cosine squared and tangent squared go together? They do? Cosine squared and tangent squared go together? They do not. Cosine squared goes with sine squared, tangent squared goes with secant squared. Question? Divide. This would be divide. No reduce, combine, or simplify. Those three words. Do not say reduce, do not say simplify, do not say combine. For combine, we would say add or subtract, and for simplify or reduce, we'd say divide. Okay? And now, so since cosine squared and tangent squared don't go together, they're not a Pythagorean ID. Like if this was cosine squared x plus sine squared x, then we could do something else. But there's not. We try to get it to one term. We can't do anything here. That sine x is nothing. So that's all we can do. We're done. I mean, if we wanted to try to make that a fraction and get a common denominator, that really wouldn't do anything either. That would just create a denominator. Because cosine, we could change to 1 over secant squared. Sine 1 over cosecant. Tangent, sine squared over cosine squared. That doesn't help us either because none of those denominators are the same. So we're done. What this page was is just reminding you when you square a binomial, you can't just distribute a squared. If that was cosine x times tangent x, it would be cosine squared tangent squared. But at minus or plus, we can't do that. All right, so this first one is a proof. Again, you pick one side. So no combine, no reduce, no simplify. Those three things. No simplify, no combine, no reduce. We pick one side. You cannot move things to the left and the right. Either you're going to make sine theta over tangent theta equal cosine, or you're going to make cosine equal sine theta over tangent theta. When I look at this, it should be very obvious. Pick the left side. The left side I can do something with, the right side I can't. And again, when you write a proof, you can't just randomly put stuff on it, and you can't like show work, like put a Pythagorean idea in there all of a sudden and then skip. You have, every step is part of your proof. If you need to do a little bit of scratch work, that needs to be outside of your proof. and then go back and write what your proof is. All right, so I'm going to manipulate this side right here. So sine theta, I'm not going to change. But tangent theta, I can change to sine theta over cosine theta. And I'm going to say that equals cosine theta. And what did I do? I used the ratio ID. So how did I get from what was given to my first step? My reason would be ratio ID. Every time you write a step, anytime you write something, you have to have a reason. Every single thing you write, you have to have a reason. All right, so now I have sine divided by a fraction. I don't want to show anything in that step. I'm done with that step. I can't do anything else to that line. The next line, I show my work. Well, I can't divide fractions. I should know, multiply by the reciprocal. Fractions and fractions, that's happened a lot. Multiplying by the reciprocal. So my numerator times the reciprocal of my denominator equals cosine theta. And what did I do? I multiplied by the reciprocal. So that's what I'm going to write, what I did. I multiplied by reciprocal. You could also say that you divided, because if you divide fractions, you can't divide fractions. Dividing fractions is multiplying by the reciprocal. So divide fractions or multiply by the reciprocal. You have to write what you did. You can't just say multiply because we had to do something. Here we were dividing. We can't just change divide to multiply, but we can change divide to multiply by the reciprocal. All right, so now we're done with that step. So this next step, we have a sine in the numerator and the denominator. So sine divided by sine is 1, which leaves us with cosine theta equals cosine theta. And why was I able to do that? Because I can divide. Sine divided by sine is 1. And I got my answer. I knew the answer was cosine, so once I got to cosine, I was done. So with proof, you know the answer. Your work has to make sense. If your work does not make sense, just because you have cosine equals cosine here doesn't mean you get credit for the answer. We know that's going to be the answer. Okay, that's a given. The steps leading up to that must make sense. Once you make a mistake in a proof, then you're done. There's no way to recover. Every single step has to make sense in a proof. Other things we do in here, there's ways to recover. Proofs, no way to recover once you make a mistake in one of your steps. Now, if you mess up on the reason, that's not a mistake that's unrecoverable. The actual work is. So you can see, we've been doing this exact same work, just without the equal sign. All right, so this next one is just to simplify. So a little bit more difficult. It'd be easy if I knew what it equaled, then I know when to stop. But I don't. So I just have to look at that and say, okay, what am I going to do? So I look at these words, sine squared and cosine. Is 1 plus cosine anything? No, it is not an ID. Some of you still are trying to go to that Pythagorean ID and ignore those squareds and think that's a thing. Not a thing. Pythagorean IDs are only words with squareds and ones. So then I look at the sine squared. Well, sine squared, I can make 1 over cosecant, but that doesn't help me. So I think about my Pythagorean ID. There is a way to write sine squared using the word cosine. That's a Pythagorean ID. So I could change sine squared to 1 minus cosine squared y. That's true using the Pythagorean ID over 1 plus cosine y. So if this was a proof, I would say Pythagorean ID. That's what I used in order to write it that way. Now, I cannot just cancel. Some of you are still just canceling up a storm when you're adding and subtracting. If I had 1 minus 2 over 1 plus 8, okay, I can't just delete those ones. Okay, I can't do that. This would equal negative 1 over 9. If I just cancel those ones, negative 2 over 8 is not 1/9. Okay, I can't do that. Not something you can do, so you can't do it with words, can't do it with numbers, can't do it with words either. So now, we just did this yesterday or the day before. 1 minus cosine squared is something we can do to that. It is the difference of two squares. So we can factor that. That would be my next step. What did I do? I factored. One's plus, one's minus. Do not forget about your denominator. Some of you just forget about your denominator or numerator, and then sometimes it comes back, sometimes it doesn't. These require a lot of writing. You can't ever leave anything out. Everything has to be shown all the time. Now we can divide that. That's 1, and we're left with 1 minus cosine y. Try it. This factor, because we did not expand that, we factored that. If it was 1 minus cosine squared quantity, or cosine quantity squared, that would be expanding or rewriting it. But I had to do something else, so that would be a factor. So again, if I was writing reasons, this would be Pythag ID. This would be factor. And this would have been divide. 1 minus cosine y is not sine y. There's no squared, so it's not a Pythagorean ID. I try to get it one term, but I can't. So that's all I can do, 1 minus cosine y. So that's just like number 11, I think ended up 1 minus sine y on your classwork. It is possible to have more than one term. Try to get it to be one term. If that was a squared, we could do something else. But it's not a squared, so we're done. All right, another proof. Again, if I take away this side right here, now it's a simplified problem. So as far as your quiz goes tomorrow, there's not going to be proofs on it, but what you do today is going to help. Everything that you do in this unit is going to help you for the next quiz, because it all kind of accumulates. All right, so if I look at that right side has a lot more to do than the left side. I've never done the left side. I'm sure you could do something, but getting stuff smaller is a lot easier than making it bigger. Okay? All right, so if I took this away and I just said, simplify that. I have a fraction. I have two fractions. In order to add fractions, I need a common denominator. This one's 1 plus sine x, that one's 1 minus sine x, 1 plus sine x. So this side needs a 1 minus sine x over 1 minus sine x. That's my clever one. I can always multiply by 1. This side needs a 1 plus sine x over 1 plus sine x. I can always randomly multiply by 1. This is equal to 1. This is equal to 1, so I'm not changing the value. Now, there is another way that you can do a proof without having to write the other side. You can, since this is the left side, we could say LHS, or we could just draw an arrow. Okay, I'm just going to draw an arrow this time. 2 secant squared x, that's a lot to write every time. So I'm just going to draw an arrow down the side, but I can't forget my equal signs. This is going to equal. I can go ahead and multiply that. 1 plus sine x over, and multiplying the denominator sometimes is a good idea, sometimes it isn't. Just kind of depends. You can do it. Sometimes you have to undo it. Sometimes when you do it, it's helpful. I'm not going to do it this time. Just see what happens. Over. So what did I do right there? I got an LCD. The math thing that I did was got an LCD. Now, I'm always thinking about what do I need it to be. There's a secant here. Secant squared is the reciprocal of cosine, so we know eventually we're going to need to get the word cosine over on this right side. All right, so now, because I have common denominators, I can add my numerator. 1 plus sine x plus 1 minus sine x. That gives me 2 over 1 plus sine x, 1 minus sine x. What did I do? I added and I subtracted. 1 plus 1 was add, sine minus sine was subtract. Just add or just subtract is fine, because adding negatives, adding a negative, plus a positive, all of that, you just say add or just say subtract. Add and subtract are pretty much interchangeable. Yep. Usually if I do two things, like I write exactly what I did. So I added the ones and I subtracted. I like thinking of it like that, because I actually did add the ones and subtract it. If those weren't there, then I would just say add. Like if those signs hadn't been there, if I didn't subtract, I wouldn't have said subtract. I just added. All right, now remember, our goal is to get 2 secant squared x. We've got our little arrow coming down here. So this right here, we're going to have to actually multiply that together. So 2 over. Now these are conjugates. The inside and the outside are opposite, so they go away. So we don't have to worry about the inside and the outside. 1 times 1 is 1 minus sine squared x. What did I do? I multiply. Distribute. Multiply or distribute is what I would say right there. And now, that 2 is a good thing because we know we need a 2. Pythagorean ID, cosine squared x. My reason is Pythag ID. And cosine is the reciprocal of secant, so if cosine's in the denominator, that means secant would be in the numerator. So there is our answer. 2 secant squared x equals 2 secant squared x. The reason we're able to change 2, or think of it like if you want to write 2 over 1 times 1 over cosine squared x, that might help you over to the side to realize the 2 is going to stay where it is. The 2 doesn't move. We can't change the 2 to a 1/2. But the 1 over cosine becomes secant, and that's because of the reciprocal ID. You cannot